Thanks, everybody. Mike and I would just kind of like to give you a quick rundown. If those that don't know, EPCAMR's regional coverage area that we're involved with and partner with conservation districts and community watershed groups throughout the Anthracite region and north central PA. Just gives you just a little quick overview of the region. There on the map, you can see the county served up in north central PA, as well as the entire Anthracite region. And we all well know that over 5,580 some miles of streams are impacted by abandoned mine lands, and there's several 100,000 acres remaining to be reclaimed. But we just want to give you a quick overview of the work of the organization for us to help these groups in partnership with our state and federal agencies to look at the abandoned mine discharges and the abandoned mine lands that are enacted when the Surface Mining Control Reclamation Act was put forth. And we do a lot of technical assistance and outreach programs in communities throughout northeastern and central PA that have been, pretty much underserved communities, as well as the partners that are looking for the funding to do the assessment and the implementation projects eventually that get put forth for projects. What we were kind of, when we started this work, maybe over 15 years ago or so, one of our former presidents, Bernie McGurl, with the Lackawanna River Corridor Association, had worked with a local newspaper, and they came up with an artist's depiction of the old Forge borehole, which is up in the Lackawanna Valley. And this was one of the graphics that we continuously used. Tara Jones is here, and Mike and I use this with a lot of our programs with students and tours that we give that kind of give you a depiction of the major basins that are in the Lackawanna Valley, for instance, in the northern Anthracite region, and a number of the discharges that feed that underground mine pool, and some of the different geologic structure and the sort of geology for those two basins and where all that water is coming from. But that picture on the right kind of, well, it looks like it's more of a bituminous, flat mine pool. The depiction there generally is to show you that water is filling up at multiple levels through the multiple veins that have been mined out in that particular area, of which they're upwards up to 17 to 23 veins of coal in the northern fields that we've seen and been able to map. So this is just a general kind of overview of what initially people's thought of what a mine pool looks like from a cross section, and then if you did a graphical cut through an artist's rendition here. What we want to kind of do in this presentation is kind of give you some examples of the mine mapping work and the mine pool work that we've done over the years, and kind of lay the groundwork for what may need to be done in the future here. There's been regional mine pool models and efforts that have been put forward that are kind of, we just say they're less detailed, but the report for the water quality, quantity, and potential usage for the underground mines in the western middle and the southern anthracite was done back in 2011. And what that did was Mike and I took a lot of the historic mine pool boundaries and their elevations that were already gathered from the 1950s and 1970s and put that into a geographical information system. And then back in 2010, we did an updated mine pool boundaries and those elevations that were coming from the 1980s up through the 2000s. And that was some funded work that we had through the state. Roger Hornberger, who was mentioned, I think Dan may have mentioned him before, with the Pottsville District Mining Office, who was sort of a mentor to both Mike and I back then. It really developed that term, the multi-colliery hydrogeologic units, which are the kind of, it's hard to explain it, but the water flow paths that are underground that go through the geologic structure of the mine workings, and then the outlet at the discharges is our best way to kind of represent that complexity that we have in the anthracite region. And Roger termed that because he was just getting to the point where helping us to understand all the notes that he was given and all the connections he was making through the various collieries, while Mike and I were starting to do the 3D mapping. And Roger was just beginning to see some of the 3D mapping as we started that work back in 2010 and 11 and finished that work up. And then in 2014, we did the anthracite mine pool mapping for the southern and northern coal fields. That was some regional models, 3D models that we produced with the Susquehanna River Basin Commission. And what we were doing at that point in time, because this is before we'll start talking about the mine mapping efforts that are with the Penn State's Mine Map Atlas, the sources for the work that we were using were the sort of cross sections that was a mashup of the anthracite folio maps, the OSM folios from the 80s, the Pennsylvania Second Geologic Survey survey maps from the 1880s, and then the USGS I-Series, and then I think we used C-Series in other efforts. But this was the initial sort of groundwork that was laid at that time. And to continue on, some of the other stuff that we were doing is the multi-colliery hydrologic unit models that were the more detailed maps that we produced were for areas like the Roush Creek area for the mine pool model for SRBC in 2017. We did the Mackinac area mine pool model for SRBC in 2020. We did the Bear Creek, we're working on the Bear Creek AMD mine pool model for the Susquehanna, with the Susquehanna River Basin Commission for DEP for their, through their Section 319 program that we'll be finishing up here at the end of the summer. Then we are now currently starting to work with the Conservation District in Schuylkill County and other partners on the Pine Knot, Oak Hill, and Repelier discharges for a treatment system study and a conceptual design that might move one particular, the Reevesdale discharge back over into other part, Repelier over into the Oak Hill and Pine Knot to be co-located for a treatment system to bring that water across a barrier pillar and maybe manipulate and look at the storage potential to treat in one other location as opposed to maybe treat 3 places. And then Mike's going to talk about a little bit later here is a traffic signal approach to mine subsidence and infiltration losses above previously mined areas in the Northumberland County, where we worked with the Northumberland County Industrial Park back in 2018. And then we did some work with Jason and Terry Ostrowski from the Earth Conservancy here up in the Wyoming Valley in Nanaco Creek on a project that is ongoing right now that they're doing a major restoration project on with $17.5 million, you know, through bill money and other funds that are coming in to do that stream restoration work. Sort of just give you a quick look at some of the maps that we'll touch on just a bit here. This is the historic kind of mine maps for the eastern portion of the western middle fields that we were able to take a look at, and we put a lot of structural control points, and the information that's in here is for the, I think it was the Buck Mountain. Is this the Buck Mountain vein area?
These are the ash mine pools.
Okay, yeah, I'm trying to say the colors on here, if you could see the brownish color are the older ash mine pools that we first took a look at, and that's back when there was still pumping going on, so we were able to utilize these before we went out and added some additional data for the updated information we got from the borehole elevations that will come later. So then when we looked at the current mine pools, when we went out, we adjusted those, we call them the beach lines, but we adjusted the elevations based on current mine pools, where in areas where there were no more pumping going on, we were able to get another elevation point that really allowed us to expand the pool to the boundaries of the coal measures in that area, using the structural control points of the geology in that area. And then the third one, you saw this a little bit in Dan's presentation, is sort of that multi-colliery hydrologic units where we started breaking up the mine pools based on where we knew where the barrier pillars that you see listed there in Roman numerals, if they were either intact or some of them were permeable, some of them were semi-permeable, like they're breached. They each have an altitude of effectiveness that maybe water could fill up and flow over. Some of them, in reading some of the reports that we had areas that they were drilled through, and so we incorporated all that information into this to know how to kind of take a look at, is the water connected in these areas, and that's how we ended up grouping them into those 19 MCUs that you heard Dan talk about before. If we look here just at a picture of the Shamokin watershed, like again, that historic orange color that you see there was the ash reports and what it looked like then, and then the updated mine pool boundaries in the mined out areas that are there is that aquamarine color, and you can see the barrier pillars that are still in there that are black and gray. It might be a little hard to see on this map, and then the brown area is really the coal measures. The brown is the outline of the coal in those particular basins across a number of valleys and ridges that go from one side of the valley to the other in Shamokin watershed. Here, you want to go forward and talk about this one here. We did some mine mapping videos. This is an area that maybe Mike could talk a little bit more about, but this was the area down in the Black Creek watershed that we worked with Susquehanna River Basin Commission on in taking a lot of the points to try and figure out how many basins are there, or, down there, and there was one tunnel discharge called the Mackinac Tunnel, and none of this was mapped before. There was an old Black Creek report that was kind of incomplete, but it had enough information on there that we were able to take all the points and create several files and layers of the various coal veins that are down there. What you're seeing is the red, as this kind of goes back and forth up and down the valley, the red is the lower red ash vein, the yellow is the Ross vein, the blue is the Baltimore vein, and I think you might see an orange pop up in here a little bit. That's the Hickory vein. And what we found after looking at a lot of the maps and after we painstakingly put in a lot of the points in here from those mine maps down in that part of the valley in the southern portion of the northern anthracite field in the Mackinac area, was that there were these underlying rock tunnels, and the rock tunnels were what were connecting each of the basins to drain down to the Mackinac Tunnel before it entered the Susquehanna River. So all of this was mapped, and we were able to show in the 3D model, how that was carrying the water down to Mackinac and out to the river. But it was also showing us where we call mine pool manifestations at the surface, where the mine pools that were interconnected were why that we had flooded strip pits in that particular area. And then we also were able to drill a bunch of monitoring boreholes that, as we did those, we were down 86, 89 feet before we actually hit the original stream channel. So the entire valley was filled up to 86 feet of fill material before we got like rounded cobblestone and the original stream channel for the Black Creek that far below. So this model helped to show that, and you could take a look at this on our website. But I'll let Mike carry on from here and talk about more of the tedious steps of the processes of mine maps and what we've gone through and the staff have gone through to do this work, and show some other examples of work that we've done.
Good, yeah. So this was done in ArcGIS. These are what is known as a multi-patch layer. So these are actual 3D structures that are virtual, kind of like virtual Tupperware. It's got a top, a bottom, and sides. And with this, we were able to calculate volumes of water that are there underneath the ground. So that was really one of the bigger steps that we were able to take with the help of folks at SRBC, especially Pierre helped us figure out how to do a lot of this. We were using a program before this called Earth Vision, and it also simulated volumes, but it was a little less exact. So this was actually taking the actual voids themselves and being able to calculate from there. So yeah, why aren't we done yet? Well, we started this journey with the PADEP MSI program. We got our first mine mapping grant back in 2015. It has been 10 years worth of work to scan. So far, we've counted over 24,000 maps that we at EPCAMR have actually scanned. There's been more statewide. Then you have to go through and catalog these maps into the PA Historic Underground Mine Map Inventory System, FUMIS. I think others wanted another name for it, but it came up with this. So if you guys have ever visited the Mine Map Atlas, this is the other side of it that tells you information about those maps. The next step is to georeference those maps, and you can't just use any control points. They have to be ones that are there, that existed at the time when the maps were being made. As you can imagine, decades later, the surface has really changed, and so this is a difficult process. Then the next step is that we make these mosaic data sets. So what we do is we try to find the best maps per colliery for one vein that stretches across the entire area. And that's kind of difficult as well to do. We've been working with other grantees. One of them was Harrisburg Area Community College. Another one was Harrisburg University, and they were ones that were sharing in a lot of this work with the mind map program. They individually set up these mosaics, and we were there to go ahead and quality control and finish them off. So they would basically do like a first iteration of it, and we would fix them. And then the last step there is to vectorize all the points and polygons that were on those maps. So, and then the last step then would be to do the 3D modeling once you get all that information put together. So it's a tedious process, to be sure. So a lot of you guys know, sorry, a lot of you guys know the Mind Map Atlas. At this point, I've heard some people mention that they visited it. It just recently went through an overhaul where they are now adding in these mosaics in the bituminous region. And pretty soon we'll be getting our mosaics fed into the system for the anthracite region as well. But if you need it, that's the link to get there. Like we said, it's a free and open system to download these maps. Some are georeferenced, not all of them are. We're still working on trying to get that done. So here's an example of a surface map. This is in Scranton near the Bellevue Colliery. And it basically shows you where all the different roads and houses and streams were at the time. So this is what we use to georeference to a aerial photo and try to get it as good as possible. This is an example of one of the underground mine maps. I'm not sure exactly where this one is from, but it shows you the structure of the mine, these being gangways through here. These areas are, where they actually mined through room and pillar. You've got your tunnels that are either connecting from one vein to another. A lot of times when you have these sections here, these are like the main gangways where they would bring things out to either a shaft or a slope that would be here at the surface. So trying to interpret these was a big step that Roger Hornberger really helped us. As you can see, there's no legend to this map, and that is probably on purpose. Also, these companies each one of them had a different way of drawing these maps. The symbology is a little bit different, but there is some general symbology that is similar. So that's helpful sometimes. Another part of it here is a cross-section map. This happens to be the Centralia mine that I think a lot of us would be familiar with if you visited, the burning fire that's making its way from Centralia all the way towards Mount Carmel at this point. But you can see here that this is where the water level is for the Centralia tunnel. So, the burning was happening on this side. There was fear that it would jump and go underneath and come over and start burning the other side. That wasn't going to happen because it would come down here and then meet the water and then extinguish itself. But it did come, rather than going vertically, it was moving horizontally. So that's that. That's a cross-section. So why do we process these old maps? Why do we have to? It's because ArcGIS can't figure it out itself. Usually when you first bring in a map, it comes up somewhere near the equator, which is never helpful at all. Then you have to find these different georeferencing points that are on here. I mentioned that it's always helpful to pick a building that still exists. Some of them are torn down. Sometimes you still have street, intersections that are helpful as control points. So yeah, here's a few down here, the bridges. So it was nice that in the northern field that a lot of them actually had a grid system, and we found this in the western middle and also in the southern field, a little bit less, but they did still have grid systems for each one of the coal companies. But as you can see here, you can't line up, the underground mine maps to a neighbor system because that's completely off. So you always had to start with the surface and work your way down. So this is just a really quick go through of georeferencing, how you place the points, The first one helps get you in the right place. The second one rotates the map. The third one brings it into scale. And then the fourth one starts to actually introduce this, what's called residual error. But we use a first-order polynomial process. That's only, if you're a GIS nerd like me, you would know what that is. But it's the default setting for the georeferencing. And we try to keep any of the error below 5. That way, it can be a lot more, you can just guarantee that it's a little more perfect that instead of having like a higher error rate. So this is kind of what the Mosaic data set looks like. Like I said, it was like a quilt of the different veins, or the same vein from different collieries. So this here is a 400 scale map that we usually start with, so that at least we know like where you know, the vein exists, and then we start looking for these more detailed 100 scale maps. And this is kind of what the structure looks like in ArcGIS. That's a Mosaic data set. Here's another example of just how we've used these footprints to kind of cut out, you know, which, you know, where we want to show the maps and how they overlap. And yeah, the next step then is, again, vectorizing the data. We go and find a drift. So these are marked, the mine entries are marked, the elevation points are marked. So here's some examples of what, you know, shafts look like. That's a 4-compartment shaft. This is just a 1-compartment shaft. This is an example of what the elevation points, yeah, hand-drawn. If you're trying to zoom in on these, sometimes, I don't know, is that a 3? That could be a 9 or an 8, I don't know. Could be a 6. So you really have to look at the data that you're putting in, and you really have to think through it. Is that right? Compare it to the other areas. So a lot of error can come in that way as well. And then here we're tracing the underground boundaries. So that gives you the sides to your Tupperware that I was talking about before. And so here's what it looks like if you were to layer, you know, the different veins on top of each other, for example. This is in the Pine Brook area. Again, Scranton area, Manville, Diamond. So this is, you know, what the boundary looks like. These are all the elevation points, and these are shafts or entry points to the mine. All things that we need to identify for the mine mapping program. So then what we like to do, and this was for the for our Shikshini work that we're doing currently, but we wanted to know where the breaker was. And so this is like an aerial photo showing you where the cone piles were. You can definitely see that on the surface. And the stream that used to come through here, that's not there now, but there is a culvert that takes nothing underneath this road. So at least, oh, there it is. It used to be there at one point in time. And so the idea is that potentially we could work to restore this stream channel as well onto the surface and stop it from going down into the mines. So that's the stack house. So here's an example of where the underground mines are underneath the ground. If it was hashed like this, those are gone. The coal is all gone here. If you see more of this one blank one up here, that's a remaining pillar of coal. So that's cool. That area won't subside, but everything around it will.
To give you a quick idea, that was just like the Dogtown problem area, which is in the southern part of the northern anthracite field at the tip, but that's on Game Lands 260. We're working with the Game Lands and the Conservation District that was recently awarded a grant to do some monitoring of some of the discharges that are coming off of this particular area, both down in the Rocky Run and Patty Run watersheds. This one is drained into the Rocky Run watershed, so all those pictures
this is the tunnel.
They have back gates that are on the tunnels, but they don't have anything to treat. They're not treating the water coming from the tunnels, and they're going to a trout stream. And the trout stream is kind of like just stunted native brookies that are in that tributary to the river. So we took a look at that for the project, and we're able to incorporate all this by utilizing the map overlays through a transparency of each of the veins to get us to right where the points were, those openings were, and we built that into the project that we worked on with the Conservation District and Larson Design Group.
So it's nice that you can go and take photos with your phone, and you can actually plug them right into ArcGIS too. So like, if this was interactive, I would be able to click here and you'd see a picture of the tunnel. And I think we were taking pictures of the culvert that was going underneath, like there was a road, an access road right here. So it's really good as an assessment tool, but it's nice to be able to see these mind maps as you're trying to go out and assess the area in ground truth at all. So yeah, we're talking about this traffic light analysis, which I think is a really interesting thing, and we've been called on by municipalities and counties to identify their lands and what's good to build on, what's not good to build on. Is this, if I build a building here and the parking lot over here, are we gonna have issues where, the parking lot's gonna start to subside? Good, maybe, yes, no, but you can tell by lining up these maps. So yeah, two examples that we have are the Sedco Industrial Park and the Nanticoke Creek Restoration Project. So here is the Sedco Industrial Park. As you can see, there's areas here that I've marked that are 0 to 50 feet below the surface. Not a good place that you would probably want to build. So I marked no, 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 and no. And then here, UGG, I wouldn't maybe, and Walmart placed right in between UGG and caution. So that's where Walmart is built. And for those locals know that Walmart has had some problems with some subsidence around their building, so. Okay, so this is the Nanticoke Creek flow loss study. Up in the headwaters, it's an average of 1,000 gallons per minute. Above the coal measures, so that's here. Holly Street is here.
Trout Stream.
Yeah, Trout Stream up above, really nice cold water. And then you get down here, and that's what the channel looks like, no flow. And that was taken on the same day. For real, I'm not BSing you. But yeah, this tells you, the areas that are 0 to 50 feet below. There's a huge hole that we dumped some dye into a few months ago, and it bright green, and it all disappeared, and we don't know where it went. It never popped up in any of our readings or anything like that downstream, so we're hoping to maybe repeat this study at a different time and map those mines a little bit better to see if we can connect it to the Ascom discharge. But there's no green on this map because it was muddying up the map, but there's also, I showed where the strip pits are and where the outcrops are, based on some other mapping that I had, so. This was actually pretty helpful when Earth Conservancy was trying to decide, or the engineer was trying to decide where they, would focus their efforts on lining the stream channel and trying to keep the water back on the surface.
Yeah, to the left side of that stream was we're right at the interface between the Pottsville and Llewellyn Formation, and the bedrock material was right underneath the stream, and they took all the coal, obviously, from above it, and then down the sort of old slope entry that went into the mines there, that are basically just whirlpools, and it's gone, and we could walk 10 feet below that whirlpool, and we have no water, and that's the point at which Earth Conservancy, is looking to do the restoration to keep like 15,500 linear feet of stream on the surface and reconnect up Nanticoke Creek. And if that happens, that 1,000 gallons a minute, multiply that out per day, but that doesn't get into the mine pools because of Mike's been able to help locate where they might be able to have to work around these areas, because it's all been moved. That whole area, back in the early 90s, and I was an intern for EPCAMR, there were still the wooden flumes, and they're all gone. And that was one of the first places that we got to do some investigation work on initially almost 30 years ago.
All right, so one other thing that I just wanted to point out, digitizing areas without mind maps. There are areas that we just can't find any mind maps at all, but a lot of times there will be cross-sections that are available. And so we did a lot of this work when we were trying to put together the northern field models. And this was done in Earth Vision, still is done in Earth Vision, but it's a tool that's called 4DVX, heads-up digitizing, that actually was developed by Dynamic Graphics and Mike Dunn out of the Pittsburgh office, which you can basically line up these cross sections on like a curtain. So your line of section is here, and then you drape these down, hang them on the clothesline, and they'll actually, depending on, how you adjust this, you put, so this is 0, you can see that it, well, you can't see it, but I can see that it says data mid-tide, and then, so these are the elevations then on the side. And what's really nice is if this plays, how do I do it? So then it allows you to heads up digitize and place points along that. So this is just a video that's showing you, we're placing these on the lower red ash. Ooh, that's cool. I don't know what's going on there, but it'll continue to place points along that vein. So here's, in the stack house, we did not have a lot of maps. So this would be for the Mackinac model. And we use that heads-up digitizing method and display those curtains across. And you can just see how many curtains were there. These were old, like, bluey style maps or cross sections. And then that's how we were able to calculate where, these, the voids were.
Each color there represents the different veins that are lying on top of one another, and we have the thicknesses of the veins, so we can even do a coal volume calculation from the thickness that remains in that area there. But that's what stretches all the way back down across the Susquehanna River and then over into the tip of the southern part of the northern coal fields that we're working on.
The river is here, and you can see there is actually like a tunnel that comes out here, but I don't think there's any water that comes out of that one. It's one up here that there's a discharge that comes down over the hill. So I think that's it. That's all that we have. Here's our contact information, and yeah, we'll hold questions until later.